Hello everybody and welcome back to the moshix mainframe channel. This is moshix. And you may remember that in the previous video I created a program that would be able to report on certain IPL parameters or any other nucleus information that we can obtain by mapping nucleus tables onto our own address space. I explained at the beginning that in each and every address space, including this address space here that's running here inside a TSO session, the operating system nucleus and all its tables are mapped into that address space. And so by using certain macros which we have in assembler, we're able to obtain some information or all the information we need from those tables, even while those tables are being updated constantly by the nucleus. What I didn't mention in the previous video is that even though I used this assembler program you see here to obtain that information, there's no need to do this in assembler. Rex can do it, PL1 can do it, even COBOL could do it, certainly C can do it. And I think IBM has some examples on this website, on the reference website, on the Knowledge Center, on how to use C, PL1, Rex, etc. to obtain that information. And it may be the easiest way to do it, especially because some information is in binary format, which requires some manipulation to change that information into something that humans could read. But what we're going to do today is, instead of producing a batch job that just such as the one you're seeing here right here, as you can see here, we compile, link, and go, and then the assemble program that's included here below will then be executed. And each time we want to reobtain the information, we'd have to rerun the batch and go to the spool area and look at the output, or have it printed and sent to us through some means, and that's a little outdated. And I've also had lots of emails and messages and comments from people in our moshix mainframe channel community saying, how can I do stuff on the terminal? Let's bring it fast forward to the late 20th century. I'm not even talking about to the 21st century where we're in now, but let's bring it to the 80s and 90s where people had monitors and had 3270 screens. And so how can we use the screen for interactive processing? So what I thought is, I'll take this utility to the next step and do two things. First of all, instead of having it running as a batch job, we'll make it so that it will be an interactive program that we can call from the TSO screen, from a 3270 screen. Second thing is, we're going to enhance a little bit, report some more information, and format it a little nicer so that it will look nice on the screen. Now, for this to happen, before I start programming, obviously we cannot go with the procedure for compile, link, and go anymore. We would have to change it so that we compile, link, and save the binary as a load module somewhere, so that then it can be called again and again and again. So this is what we're going to do in this session. I intend to do what I did in the previous video, even though I haven't received yet any feedback. If people like it when I sit down and program and remove the sound of the clinking of the keyboard, and then accelerate in the playback, accelerate the tempo so that it will scroll much faster, and it's going to be much more interesting, I think, to look at the act of programming, because you don't have all those dead moments where nothing happens when I'm thinking. So I'm going to do the same thing. Right now I'm recording it up to now, and then I will now change the recording so that the sound is omitted, and then I can accelerate the playback by about 2.5 times so that it's going to go at a good pace for you. As you can see, I'm still working here on making the output more appealing, especially since this is going on the screen now. And we're also adding several new parameters that we didn't have in the previous video in M57, such as the sysplex name, the parameters issued for the IPL, and also the name of the master catalog used on the system. And by the way, this will be working exactly the same also on MVS or any ZOS version. We obviously also need to move these new fields into the right variables with the MVC instruction. It is important to note that the MVC instruction on the S370 architecture is driven by the length of the receiver, not of the variable being moved. And of course, now you can also see that we're changing all the put into T-put, because we're not going to the output data set anymore or to the printer we're now putting on the screen. And T-put is a TSO oriented macro which requires to mention what it is we want to put on the screen and the length of it. And for this we use the assembler L apostrophe facility, which is an assembler related instruction. Again, here we need to put in the field we want to put on the screen as well as the length of it. And the L apostrophe tells the assembler, not the computer, but the assembler, what is the length of the field being put on the screen. Always have sensible commentaries in your assembler. Makes it much easier for other people to debug your code. I'm looking up the names of the fields we get from the IPA area just to make sure we don't have any errors. Trying to get this to compile as cleanly as possible. Checking everything again. And here again, the IBM Knowledge Center provides all the documentation we need. Given that the MVC is driven by the receiver length and not by the field being moved, I have suspicions about this code executing correctly, but I'm just making a mark here in the source code, so it's going to be easy to find if we have a dump or if the program abandons. Okay, this looks ready to give it a spin. I think we've checked all the things we needed to check. Let's see what comes out. Okay, so we switch back again to normal speed playback, and let's see what we have the output. So we produce the output, this ran. It is obtaining, I think, most of the output, but it's all in the wrong place. Something we had also in the previous video. So this seems to be in the right place. This is the IPL device, I recognize that. The Z9 sys1 should be, the volume serial should be over here, but it's not. And the catalog, it was truncated as I was expecting. And then this should be more to the left 2 bytes, and this should be to the left 3 bytes. So 2 and 3 for the last one. And then let's look what's wrong with the above one. So let's go back and so first of all, we have to delete this because otherwise it's not going to override it automatically, and we'll just keep on looking at the old load module. By the way, load module is something that was already linked at it. An object module is something that a compiler produces, but since the assembler doesn't need that step in between, from an assembler you go to a load module after linking it. But COBOL, C, PL1, all those will, even compiled Rex will first produce an object module. Once you have linkage edited it will become a load module. And as I remember, this library needs to be, as I'm showing here, record format U for undefined and 327060 block size, so that it can contain load module. So let's go see what's wrong with this program here. We set 2 to the left and 3 for the left for the last parameter. So that will be this one. Outline 3 to the left, so we'll do 10, and so these are obviously the easy problems to fix. The bigger problem is how do we get the catalog name, which is 44 characters long, properly in, and that's going to be a little more of a challenge. And observe as I try to find the solution, and ultimately I will have to resolve to using a register to find the position within the line where I want to place the master catalog name. Elegance obviously is important, and so after struggling to find an elegant solution, I decided to use register 8 to load the address of the location within outline 3 where I want to store the name of the master catalog, which is again 44 characters long. And once we store that location, that address in memory where we want to place stuff, we can then use the MVC, the move character syntax, which uses a displacement and length and base register, and so we can say that move 44 characters at displacement so and so off of register 8, and you'll see this happening now in the next MVC instruction. And I think this is the most elegant way to solve this and resolve also. So here you go, MVC, move character, 44 bytes of displacement. So first the displacement, then the 44 characters of length of register 8, and we move the payload in there. And this solves our problem in a very elegant way. And so I don't have to do a lot of back and forth and just have 3 simple outlines. So let's give this a try, and it works beautifully. We just have to move the catalog serial number a little bit. So first, of course, we delete again the load module, adapt now, move a little bit the location of the system of the volume serial of the master catalog, and run this again. What we're doing here now is I'm putting in some data which is easily readable in a dump. So we have, in case we get to a dump and a bend, so we can read inside the load module dump what it is, what this program is, and that's required because we will be calling this program as a load module. We will not have necessarily the source attached to it, and so therefore these things become important. Let's give this a new spin, and this time we're perfectly aligned here, so we have all the information we need. And so this shows that how easy it is to create system utilities in MVS or ZOS. This will work exactly the same on MVS. And what I'm doing now is just showing you how to call it from the TSO command line. So you just call, and then within apostrophes, so you have an absolute path, the name of the load module. I hope you had fun watching me do this. I had a lot of fun programming it. And in the next installment, we start also to ask the user for input. This next video will come in the next few weeks as I'm traveling the next few days. Thank you very much, and have a nice Passover or Easter. Thank you very much for watching. Please subscribe to the moshix mainframe channel, and see you soon on this channel. Thank you, goodbye.